All right, so I'm assuming this is the one we need to see everything, right?
Sure.
This is the homework page. So, what intervals, this is the graph of G prime. What intervals, if any, is G increasing? Union, 2, 3, 4.5.
4.5, I got it right, let's go.
Because, justify your answer.
G prime
X is greater than 0 in these intervals.
Good.
Okay, so which ones are ones that you like look above the x-axis? Which ones are ones that you look like you look at
Okay. Excuse me, sorry to interrupt your conversations, but the ones that you look above the x-axis for would be finding G prime positive because this is G prime. G prime positive means G prime is above the x-axis. So decreasing, we're looking for the G prime's negative. So what would that be? -7, 2, and because why? G prime is less than 0, blah, blah, blah. I'm not writing it all out. Y'all can do that. On what intervals, if any, is G concave up? Now we're looking for the derivative of G prime, right? For being positive, right? The slopes here are positive, still positive, 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 negative, positive right there. So I'm going to say where? -7. You probably could get by with saying 0, but I'm going to say the second derivative doesn't exist at -2. Because that cornery thing, right? That is only if they spell out it's increasing and concave up or something. This is just what intervals is it concave up. Second derivative is positive means the slopes of the first derivative, right? But we have to say because the derivative of G prime, which is G double prime, is greater than 0. Concave down would be the opposites, right? It's going to be 0 to 2, and what? 3 to 5. Because the derivative with respect to x of G prime is less than 0 on these intervals. Relative maximum, y'all, what are we looking for? G prime changes from positive to negative. This is the graph of G prime, correct? Literally, we're looking, is it above the x-axis or below? We got negative to positive, that won't be a maximum, right? Oh, and minimum. Oh. So we got to do a minimum because G prime changes from positive, negative to positive. This would be a minimum, right? Sorry, I only was looking at maximum. So we got a minimum when G prime changes from negative to positive. What are you seeing? Negative to positive at positive to positive, nothing there. Positive to negative would make it a max.
Wait, what? I thought you looked at the slope.
These are G prime.
Wait, so what's the thing that you drew those lines and like put the plus and the
For concavity. concavity we already addressed that one. Positive slopes, still positive slopes, negative slopes, positive slope, negative slope. That's all concavity. But relative maxes and mins are the first derivative changing. The first derivative is this graph. We're only looking at positives and negatives. Everybody agree with that? All right. So, and we got, because because find the x-coordinate of each point of inflection. Now we're looking for the second derivative changing sign, right? The second derivative are the slopes, which we've done a little secant chart, right? Second is positive to positive, no sign change there. Positive to negative, we got one at 0. Negative to positive, we got one at 2. And we got one at 3. Why? Because G double prime, which is, we're showing the derivative of G prime, right? Changes signs at these x values.
Miss Washington,
Yes,
back to the maximums and minimums, is it when the line goes like from positive to negative, like the line, or when it goes on the graph, positive to negative? Do you know what I mean?
It's like when it's on the other side.
Like the line,
this is the graph of G prime.
yeah.
These are the values of G prime. G prime is -1, negative point something, point something, point something, point 0, 1, 0. Then G prime is positive 0.1. We have, our G prime has changed from negative to positive at x equals -2.
But like it's only when the line crosses from
The
negative-
x-axis.
Because 3 isn't 1, right?
Here, 3 is not 1.
Yeah, okay.
Because we got positive, positive, we still have positive, positive. They're above the x-axis. 3 is not even a critical number. The only critical numbers are the zeros of the derivative, which is what we have the graph of, right? Find an equation for a line tangent at the point 0,5. We got a point. What do we need? A slope at that x value. Well, we've got the graph of all the slopes, right? What is the G prime of 0? 2. Point and slope, y minus y1, slope, x minus x1. And no, you don't have to have the 0, but
Wait.
all right, concave down and positive slope. Positive slope means what? G prime is greater than 0, right? Concave down means G double prime is negative. We only have this interval to look at and this interval. Where is G prime positive? It's above the x-axis from 0 to 2. And where else?
But
Concave down.
the slopes are negative.
That is what G double prime is, the slopes of these. But G prime is the graph of the, we don't know what G looks like. We only know what G prime is. Is G prime above the x-axis from 3 to 4.5? Yeah. G prime of x is greater than 0 and g double prime of x, which equals the derivative of g prime, is less than 0. Same retraining of your brain.
So how do you know the difference between like a positive slope, like actually positive, and then just above the x-axis?
If I had asked you, if I had told you this is the graph of f, when is f prime negative? When the slopes are negative. Negative 3 to 0, 2 to 4. But this is not the graph of f. This is the graph of f prime. F prime is above the x-axis from negative 3 to negative 2 only. F is increasing only from negative 3 to negative 2. Whereas F decreasing from negative 2 to positive 2 and 2 to 4. You literally have to retrain your mind to only look at what they've given you. They've not given you F, they've only given you what? On this one, F prime. So looking at this graph, I know F is doing what from negative 3 to negative 2? Increasing. It's above. F prime is above the x-axis. What is F doing from negative 2 to positive 2? All the values are below the x-axis. Decreasing. F is decreasing. From 2 to 4, F is still doing what?
Can you explain that in terms of the first graph? Like, explain why H is the right answers for that graph on the one? Because when you were writing it down, we couldn't see your answer and the graph at the same time because it didn't fit on the screen.
The justify? Is
No,
it?
for H, the problem box.
Oh,
I couldn't see both at the same time, so I couldn't like comment on
concave down. See, I had already done a G double prime SIGIN chart. Concave down means G double prime is what? Less than 0. This one's out, this one's out, this one's out. We're only looking at this interval and this interval, right?
And they're both above the x-axis, so they're both greater than
Except it's above the x-axis from 0 to 2, and 3, it stops here at 4.5. It would have gone all the way to 5, but that 4.5 to 5 is below the x-axis. All right, so on what intervals? Yes,
Oh, for B, so would like,
on 2.
oh yeah, yeah. So would like, so the first interval from negative 2 to 2, would it be like negative 2 to 2, B 2 to 4 because like at 2 to
That's how I would say it. I would definitely say negative 2 to 2 and 2 to 4. Delta math would go bracket negative 2 to positive 2 bracket. That's what they would do. But this is decrease. F is decreasing because F prime of X is what? Below 0. F prime of X, all of them are below 0. Have you retrained your mind?
Can you not write just negative 2 to 4? Do you have to bring it up?
I think negative 2 to 4 might be accepted.
Because that's what I've been doing. Like, should I break it up every time?
I would break it up myself. But I think, because at that one point, you know, it's neither increasing nor decreasing to me. But it might be semantics. So if you did negative 2 to 4, I'd probably accept it. On what intervals of increasing is F increasing? We talked about that. The only interval that's above the x-axis is negative 3 to negative 2. f prime of x is greater than 0 on that interval. Now we're looking at concavity. Concavity comes from what derivative? Yeah. The second derivative. Now we are looking at slopes because we're looking at the derivative of this. All the way from -3 to 0, all those slopes are what? From 0 to 2, they're, right, positive and then negative. So this is my f double prime SIGINT chart right there. Concave up would just be from 0 to 2, right? From -2 to 0, the second derivative is negative.
I was looking at like the bottom.
On what intervals, if any, is f concave down? We've shown those. -3 to 0, 2 to 4. Why? Where does f have a relative maximum? Relative maximum means f prime is changing from f prime is going from positive to negative at -2, and no more places, right? If we want to be specific at x equals -2. Find x coordinate of each point of inflection. What goes through our mind with points of inflection? Second derivative is changing. That's where we're looking at the slopes of f. Oh, we've already written those, right? Are you seeing a sign change at 0? And where else? Because at these x values. Equation of a tangent line. At the very beginning, they said f of 0 is, so our point is, we got a point, we need the slope, which is f prime, right, of the x value. This is the graph of f prime. What is f prime of 0? Point, slope, y minus y1, slope, x minus x1. It was given, yeah. How do I get -2 for the relative maximum? Because in our retraining of our minds, we're thinking, I don't really know what f looks like. All I know is what f prime looks like. F prime is above the x-axis. It hits the x-axis. So f prime of -2 is what? What's f prime of -2? 0. But to the left of -2, it's positive. To the right of -2, positive to negative, relative max.
Like,